So we're going to do a little bit more digging of the behind the scenes of Liferay by looking at Liferay's message bus. So Liferay's message bus is a service level API that's used to send messages within Liferay. It's very similar to JMS, just without as many features as you may expect from JMS. We do support both synchronous as well as asynchronous messaging. One of the downsides here is out of the box, there is no acknowledgement of the messages being sent or them being received. One of the biggest use cases in the use of the message bus is Liferay's cluster link. So cluster link is the tool that's used to have multiple instances of Liferay work together in a clustered environment. So a couple different use cases for using the message bus. We'll highlight some of the big ones. Sending bulk emails, right? Another one could be file processing, and one of the other highlights here is auditing. But we have a pretty extensive list of some of the other use cases. So what does Liferay use the message bus for? We talked about some of the different use cases, but what are some of the other ones? Auditing, again, is going to be a very big one. Search engine integration, asynchronous background processes, monitoring what's going on within Liferay, and I'll hit the last one here, the hot deploy folder. But again, pretty extensive list for the different use cases that we have with Liferay's own message bus, or our message bus. So how does it exactly work behind the scenes? So there's going to be three main aspects of the message bus. So we'll first start off with the sender. The sender is the one who sends a specific message. Now where they send the message is going to be the destination. So a sender sends the message to the destination. The destination being an address or an endpoint. And at that destination, we can have listeners. Listeners are registered at specific destinations and retrieve the messages that are sent to the destination. So a sender sends a message to the destination, and we can have a listener at the destination get the message there. So visual diagram here, we can have one specific destination. We can have one sender and one listener per destination. We can also have a sender and multiple listeners, or we can have multiple senders, multiple listeners, any sort of combination of those. Let's take a look now at our destinations. Now, destinations are the endpoint to receive the message. This provides for us a loose coupling between the sender and the listener. We could just be sender-listener, but with the destination in mind, it provides kind of a layer of abstraction as well as more modularity. And this destination is also an OSGI service. Now, with our destinations, there are different types of destination, 3 specifically. So we're going to have a parallel destination. The idea here is all of the messages are going to be queued up or lined up, and we can have a thread working for each message for each message listener. So you have 2 listeners on a destination. You have 2 threads working for each message listener. Okay, or you can have many depending on the situation. Serial, right? Same idea. Right, our messages are queued up, but we'll have 1 worker thread per message that comes in. And then finally, synchronous. This is going to be sent directly to the listener. So no queuing up, it's just going to go directly where it needs to go. So a couple of different examples here. Typically, when we're dealing with parallel destinations, it's going to be asynchronous. So the idea here is we have a sender sending a message over to the message bus. The message bus will then determine where it needs to go and send off the message to the specific destination. Let's assume we have 2 listeners here, And these listeners can be processed parallelly or in parallel. So one thread working for each message for each message listener, all the while the sender is just kind of progressing on doing whatever it is that it's doing. So asynchronous parallel, right? Send it, have it processed, and I can still do my thing. Contrast that to sync serial destination. The idea here is you send the message bus will send it to where it needs to go, and we still have the parallel, in this case, it would be the serial destination. So we'll process it right, one at a time. You have one thread for each message. So if each message is for each listener, right, goes through the first message listener, sends it off there, goes through the second one, sends it off there. All the while, the sender is kind of blocked. It's waiting for the message to be processed, and once we receive a response back over at the sender, it can then proceed on with whatever it was that it was doing. So how do we configure the destination in the first place? First thing we need to do is register the destination. So as we're registering the destination, what we can do is first create a destination configuration object. That configuration object can then hold all of the configurations of the destination as we create it. So what is its name, what type of destination it is, parallel, serial, or synchronous, and so on. What is its queue size, things like that. So once we have all of the configurations stored within that configuration object, we can then create a new destination based off of that configuration object. After that, we can then register it so that Liferay knows about it. Or I should say, the message bus knows about it. So those are destinations. Next up is going to be senders. So senders are the ones who are sending messages. So a message can either be directly to the message bus, asynchronous, or synchronous. So asynchronous uses a single destination message sender. Synchronous uses a synchronous message sender. So if we're sending direct, here is an example here. We can create a method called sendDirectMessage. Within it, right, we create a new message. We then will say, this is the specific destination that I want to send this message to. This is the message itself and its context or its contents, and then send it to where it needs to go, right? Having all of the information there. So we're going to send it to the message bus saying, hey, message bus, here is our message. Here is where it needs to go. You take care of it for me. So that's direct sending. Asynchronous, the idea here is a message is sent, and then the sender can then continue on with whatever it is that it needs to do. Now, when we send a message, we can also have a callback. The idea here is, right, once the message is received, we can let the sender know. In order for this to happen, though, we need a listener. So sending a message asynchronously, right? We're going to have our method here. We create our message. We set where the message is going to be sent, what destination, and then from there, what we're going to do towards the bottom is we're going to create this message sender object. When we create the message sender object, right, we're going to be creating it using that specific class that we mentioned earlier, single destination message sender. So we create that object, we pass the parameters of where we're going to be sending the message, and then we call that message sender object to send the message. And then synchronous. So synchronous, right, is the one where we're going to be sending the message synchronously. So send the message, wait for it to finish, and then we continue on. So when we're going synchronous, right, any other threads, or what it does is it's going to block the threads until a response is either received or we just time out. So again, send the message, wait until we get a response, or we quit after a specific time frame. When working synchronously, there are two different modes we can work with. We have default, so this is going to spin up a new thread with a specific timeout, or direct, right? We're going to be delivering the message in the same thread, and so the thread is both for sending and receiving. Okay, so example here, very similar to what we've seen before. Create the message, set where we're going to be sending the message to, and we're going to create this message sender object using the create single message sender class. So that synchronous message sender we saw a little bit ago, right? And then same idea, have the message sender send our message, and then we set a specific timeout, in this case in milliseconds. Listeners. So we hit destinations, we hit senders. Now at the destination, we're going to have a listener just listening. When we're creating these listeners, we need to register which destination the listener is going to be at. And so when we're doing this, we have three different ways. We can do it within the component annotation, just basically as a property set which specific listener we're listening for. We can do it through the message bus. We get a reference of a message of the message bus object, and then through there we can register the listener, or we can do it through a destination, obtain the destination reference, and then set our listener there. So component through the message bus through the destination. So let's take a look at through the component, which is the automatic way. So within the component annotation, we have the property element, and then from the property element, you have the property destination name, the destination that we're going to be registering this listener at. If we want to have our listener work in the cluster, we can do that as well using this cluster bridge messenger service component. So that's also possible. So for this example here, if you look down towards the bottom at the @reference object, right, we're going to be targeting our specific destination, and we first start off by registering the listener at this specific destination. So get a reference of the destination object, and we're going to target our specific destination that we want to register at. So when the listener is activated, we're going to be creating this new cluster bridge message listener, and then with the destination object, we're going to register our message listener at this destination by making it a cluster bridge listener. All of that to say, registering the listener as with the ability to listen across the cluster. So the message bus and service builder, how do they exactly relate? So we can, within our service builder project, use two specific annotations to kind of help us out. The first one is going to be async. So any method that we create in our service builder project that's annotated with async, it's going to pretty much be an asynchronous method call. So pretty simple there, right? So the idea here is, right, call the method. It's going to be kind of a fire and forget. Just call and it's done. That's it. So this is especially useful when we want some sort of notification system. Second tag we can use within our service builder project is clusterable. So clusterable, what this allows us to do is, well, just that, right? This specific method can be called or invoked among our cluster. When we're using this annotation, there are two attributes that we're able to use, onMaster and acceptor. So onMaster, we can set this attribute to true, and the idea here is the method will only execute on the Liferay instance that has the master token. Or acceptor, right? You can call this pretty much any Liferay cluster, any Liferay node is able to invoke this specific service. So clusterable method or service can be called in the cluster environment, and we can control either there is a master node that's able to call it, or anybody can call it within the cluster. Now, message bus stats. We can take a look at what's going on within the message bus, and when we do, specifically with the destination, we can see these as mbeans. So if you have something like jconsole, for example, you can run jconsole and take a look at the various attributes and settings, destinations, and so on within the message bus. So with all that being said, all right, this is the sort of message bus in a nutshell. So let's go ahead and we'll move on to the next section.